I'm sorry, students, somehow my non-disjunction videos did not record, so I'm going to just record both non-disjunction and meiosis 1 and meiosis 2 on this video, and I will try to make it as neat as I possibly can. So let's start here with a cell, and let's give it a number 1 from mom and a number 2 from mom, number 1 from dad, and number 2 from dad. And then we're going to duplicate them to get them ready for meiosis. Okay, so this would be prophase 1. Okay, and then we're just going to go into metaphase, line them up as homologs. And now we're going to have a non-disjunction event, meta 1, we're going to have a non-disjunction event in anaphase. So somehow, like let's say this rope didn't quite attach, okay? And so when anaphase comes along, anaphase 1, the 2 chromosomes get pulled one direction, like so. So this rope just kind of failed to attach to the chromosome. This is what we would call a non-disjunction event, non-disjunction, okay? And so if we were to continue this on and just go, I'm going to just kind of jump through telophase and cytokinesis and end up with our 2 cell types that we're going to get, okay? So one of them is going to have both number 1s that stuck together, and then it'll have number 2 from dad and number 2 from mom is over here. Okay, so if these were to split again, and I'm just going to simplify this, if these were to split again, just skip the phases because we've already drawn them a bunch of times, we're going to end up with these 4 gametes. So these 2 are going to have 1 from mom and 1 from dad, and then 2 from dad. Whereas these 2 are only going to have the 2 from mom. Okay, so if a normal sperm, let's say we have this normal sperm that just has a 1 and a 2, if it fertilizes one of these 2, we're going to end up with a trisomy of the first chromosome, right? We'll have 3 number 1s, 2 number 2s. If it fertilizes one of these 2, we're going to end up with a monosomy, only 1 number 1 and 2 number 2s. Now, let's contrast this with a non-disjunction in meiosis 2. So same thing, we're going to start out in prophase with moms and dads numbers 1 and 2. Move down to metaphase. So we'll have metaphase happen normally. The ropes will attach normally and everything will happen normally. So all the ropes made it. So we're going to go ahead and separate. Okay, so I'm going to dot, dot, dot till we have our 2 cells. And they each have, this one has number 1 from mom and number 2 from dad. This one has number 1 from dad and number 2 from mom. Okay, but now we're going to have a non-disjunction event here. So when this lined up, let's just draw metaphase here. Whoops. Let's draw metaphase 2. So this is meta 2. And in this case, let's say that, again, the rope just failed to connect. So these ropes came out just fine, and this rope came out, but this one kind of got stuck or something. Okay, so if we were to separate this, let's go ahead and draw anaphase 2. We end up with this being pulled to one side, but this one is actually getting separated. Their goofy rope there. Okay, and so if we follow this out to our 2 cells that we're going to end up with after all the rest of the phases, this one over here actually has 2 number 1s, both from mom, and then the number 2, and this one only has the number 2. It missed its number 1. Now this cell could easily split normally. There's no reason for a non-disjunction. So let me just label that non-disjunction. There's no reason for a non-disjunction to happen in both of them. So this one could have just gone normally. Okay, so let's compare these. Oh, and again, sorry, if you fertilize these with a sperm that has a 1 and a 2, this one's going to end up as a monosomy. This one's going to end up as a trisomy, right? So let's contrast these. If you have a non-disjunction in meiosis 1, you get all 4 of the offspring daughter cells are bad. They're an aneuploid, right? They got the wrong number of chromosomes. Whereas if it happens in meiosis 2, generally you only get 2 bad ones, whereas the other 2 are okay. The other thing to really take note of, I'm going to circle it in yellow, is that in the trisomy, the duplicate chromosomes, if it happened in meiosis 1, those are homologs, so they're not the same. Whereas if it happened in meiosis 2, they are sister chromatids, and they are identical unless some kind of crossover event happened. Okay, so that's something to keep in mind. If it happens in meiosis 1, you have homologs as your duplicates. If it happens in meiosis 2, you have sister chromatids. Okay, so I hope that makes sense. You can see it all there side by side.